Welcome back. In this video we will learn about motion, and then we'll see the concept of distance, speed and time, and we'll see how to convert between kilometer per hour and meter per second. Then we'll see what is called as relative speed. Then we'll see what is acceleration. Then we'll see how to approach problems on train, and we'll see how to approach problems on boats and streams. Then we'll see the concept of work, and then we'll see what is negative work, and finally we'll see the concept of efficiency. So let's get started. First we'll start with motion. So motion is nothing but when any object changes its position from one place to another, then we say the body or object is said to be in motion. And distance is nothing but how much the object is moving. So it may be with respect to any point. So let's say if we take from point A to B, object moves from point A to B. So how much it has moved is called as distance, and it is represented by D. So the amount by which the object has moved. So time we know, and how much time it takes to move from A to B. So time is already there. It is a universal quantity. So speed is nothing but rate of change of distance with time. So how quickly the object can move from A to B, that is given by speed. So speed is given as distance by time. So now we can also introduce the concept of displacement. Sometimes instead of distance they call it as displacement. So what is the difference? So distance, suppose this is the object, let's say it moves from this thing. Okay, so initial point is A and B. So the shortest distance between A and B is this red line I'm drawing. So this is some, let's say 10 meter. Then this blue curve, if you go by blue curve, let's say it comes to be some 15 meter. So displacement is nothing but shortest distance between starting and ending point. Distance is the actual path covered by the object, but displacement is just the shortest distance. Okay, so with this clarity we'll then see what is velocity. So velocity is rate of change of displacement. So we have displacement by time. So for an object in straight line, motion in straight line, both distance and displacement are synonymous, because like A to B it travels in straight line, then the displacement is also the same as this straight line, so it is both as same. Similarly, so if these both are same, then speed and velocity is also become same. Okay, so we saw what is distance, speed and time. Then next we'll see conversion between kilometer per hour to meter per second. And before we go into that, if you see, we have speed. I'll say it as S is equal to D by T. So S is directly proportional to D. We saw the variation, right? So if D increases, S also increases, and S is inversely proportional to T. So if T increases, S also increases. So in this, what is kept constant? T is constant. Then S is directly proportional to T, and here D is constant. And we also have D is equal to S into T. So D is directly proportional to T given S is constant. So this constant term is also important. Then only we can say how one quantity is varying with the other thing. Okay, so now we'll see conversion. To meter per second. So speed, as I already said, it is distance by time. For example, if you take a car in a daily life, suppose let's say I travel a distance of 60 kilometer in 1 hour, then the speed will be 60 kilometer per hour, correct? Because it is kilometer by hour. So kilometer per hour is a unit of speed. Similarly, if I travel 60 meter in let's say 10 seconds, then the speed is 6 meter per second. So it is just a different units, meter per second. This is the SI unit, and this is the one we use in daily life. The speedometer in the car shows this numbers only. So if you want to go from this one to this one in some cases, for example, if you want to express the answer in terms of meter per second, so how do we do that? So we'll take 1 kilometer per hour. So this is nothing but 1 kilometer by 1 hour, and 1 kilometer is nothing but 1000 meter, and 1 hour is 360 minutes, and 60 minutes is nothing but 60 into 60 seconds. So now if we simplify this 0, 0, 1, we get 10 by 36 meter per second. This again we can cancel 5 and 18. So 5 by 18 meter per second. So 1 kilometer per hour is 5 by 18 meter per second. Suppose we want to convert 18 kilometer per hour to meter per second. We just multiply 18 into 5 by 18, which will give you 5 meter per second. If you want to go from meter per second to kilometer per hour, you just multiply by 18 by 5, because 1 meter per second is 18 by 5 kilometer per hour. So this is important. In some questions we may need to use this. Okay, so we covered this. Then we'll see relative speed. Okay, what is concept of relative speed? Let's say object A travels at a speed of 10 meter per second, and object B travels in the same direction in the speed of 5 meter per second. So this is 5 meter per second and 10 meter per second with respect to a stationary observer standing on the ground who is not moving. But if you see with respect to B, so if we keep B as fixed, then A is moving or will be appearing to move at a speed of 5 meter per second, right? And the stationary observer will be seem to moving backward at the speed of 5 meter per second. So this happens, right? If we are in a train and suddenly the nearby train starts to move, or we start to move, sometimes we feel that like when the nearby train is moving, we are itself moving. So we get those kind of feeling is because of this relative speed concept. So if object A and B are traveling in the same direction, their relative speed of A with respect to B is SA minus SB. And if A and B are traveling in opposite direction, the relative speed, I'll denote it by S itself, of A with respect to B is SA plus SB. Right? If they're traveling in opposite direction, they will cross each other very fast than traveling in same direction. So the speeds add up. So if you want to find relative speed of B with respect to A, then it will be SB minus SA. And here it remains same, SB plus SA. Okay. Okay. So next we'll see what is acceleration. So still now we have assumed that the objects are moving at constant speed. But if the speed itself is changing, then the rate of change of speed is acceleration. So if a car is there, so initially it is at the speed is 0 meter per second and we press the accelerator. That is why it is called accelerator. So it will start to move. It will go to 10 meter per second. Then it will increase to 20 meter per second and so on, as long as you press the accelerator. And once you apply brakes, it will again start reducing. So that is called as deceleration. It is nothing but negative acceleration. Okay. So let's denote acceleration by A. Then we have initial speed. Let's call it as U. And final speed, let's call it as V in time t. In time t, from U it changes to V. Then we have V is equal to U plus AT. Why is this so? Acceleration itself is rate of change of speed, right? So it is change in speed divided by time. So which is nothing but V minus U by T. So V is nothing but U plus AT. This is assuming that A itself is constant. Okay. Fine. So this is acceleration. So now we will see train problems and board problems, how to approach them. First we will see train problems. So for an example, there is a platform of 100 meters long and the train itself has some length, right? So train itself, let's say, is 600 meters long and it is traveling at the speed of, let's say, 10 meter per second. Then the question would be how long it takes for the train to cross this platform. So in that case, if you see the total distance, let's take the train as at the edge of this platform. Okay. So total distance is 700, right? So the total distance is nothing but length of train plus length of object. And the speed remains same of train. So speed here is same as speed of train. So time is nothing but distance by speed, right? So here it is 700 meter divided by 10 meter per second. So it will take 70 seconds for the train to cross the platform. Suppose this platform is stationary, right? So instead of platform, it is some kind of, let's say, car in the road. Okay. So there is a car and it is moving with a speed of 5 meter per second. And this car has a length of, let's say, 50 meter. The train is same, 600 meter, and it's traveling at 10 meter per second. So now how long it takes? So again here the total distance remains same, right? And what is the speed now? The speed is nothing but the relative speed. So the car is at 5 meter per second and the train is at 10 meter per second. So the train will see the car moving at, or the car will see the train moving at 5 meter per second only. So the speed is nothing but relative speed of train with respect to car. So this is nothing but S train minus S car. Now if they are in opposite direction, like they are moving in opposite direction, then this will be S train plus S car. So this is how you solve the problem. Suppose if it is just a pole, they say it is just a pole, the train needs to cross the pole. So pole has, let's say, almost zero length. It is just a stick kind of thing. So it has zero length. So the distance will only be the length of train. And speed also only will be the speed of train. So then you can find how long the train will take to cross the pole. So these are the most common type of questions in the train problem. So now let us go to the boat and stream problem. So in boat and stream problem, what they say is they usually have water flowing, speed of water downhill. So water always flows downhill, right? And they say there is a boat, the person is rowing it, and he also has some speed, so S boat. So when going uphill, he is traveling against speed of water, right? So it is like he is on the water itself. So the boat is moving on the water. He is trying to go in this direction and the water is trying to flow in this direction. So the water is opposing the speed of the boat. So when he is going uphill, his speed will be SB minus SW. And when he is going downhill, you can see his speed has reduced. Downhill, the water is helping him go downhill. So the speed will be SB plus SW. So here you shouldn't use the concept of relative velocity because the object itself is moving on top of water. So relative velocity comes when there are two different objects moving in some path. But here it is, the object itself is moving on top of the water and the water is trying to push the object down, but he is trying to go up. So it is opposing. But on the other hand, while coming back down, he is also trying to go down and the water is also pushing it down. So even if he is stationary, he doesn't on the motor, the water will still push him down and he will still go down with the speed of SW. So this is the concept of going uphill and downhill. And questions will be typically like, he takes some 5 minutes to go uphill and only 1 minute to come downhill. Find speed of water and speed of boat. So you can set up two equations and there are two unknowns. So for this thing I'll explain. So, and there is a other quantity, we need to also specify the distance. So let's say distance is some 600 meters. Okay, so 5 minutes is 5 into 60, which is 300 meter per second. Sorry, 300 seconds, and 1 minute is just 60 seconds. So going uphill, right? So the speed is SB minus SW. It's nothing but distance by time. So this is 2. And going downhill is SB plus SW will give you 600 by 60, which is nothing but 10. So now SB is nothing but 12 by 2, which is 6 meter per second, and SW will be 4 meter per second. Alright. 6 minus 4 is 2, 6 plus 4 is 10. So this is how you solve and find them. So like sometimes they will specify SB and they will not specify D. So like totally there are 3 variables. They can give one of the variable and 2 more equations to set it up and solve them. So this is how you can solve it. And we'll see more problems on this in another lecture. So now we'll go and see the concept of work, I think. So yeah, we'll see concept of work, negative work, and concept of efficiency. Okay. Concept of work. So there are workers doing some particular work. And they will specify, let's say worker A does the work in 2 days, completes the entire work in 2 days, but worker B takes 4 days to complete the entire work. Then they will ask like how long, if A and B work together, how long will they complete the work? So these type of question. So A is doing the total work in 2 days. So we can define something called as the work rate. And time we have, and we have the work itself. So this is similar to the speed, time, and distance concept. So work rate is nothing but work done by time taken. So this is similar to speed. So whatever if we think this in terms of speed, time, and distance, it will be easy for us to solve. And work itself, right? Let's take it as a whole, or 1 or 100%. So we can just fix it as 1. So what is the work rate of A? Work rate of A will be 1 by, it takes 2 days, 1 by 2. Work rate of B will be 1 by 4. So if both are working together, the total work rate will be 1 by 2 plus 1 by 4. So this will be 3 by 4. So this is the total work rate. And how many days they will complete? So we need to find the time. So time is nothing but work by work rate. So work itself is 1 and work rate is 3 by 4. So they'll complete the work in 4 by 3 days. Right? So A takes 2 days to complete, B takes 4 days, but if they work together, they'll just complete in 1.33 days. So they finish it faster, right? So you can think of work as concept of distance and work rate as concept of speed and solve these type of questions. So this is the case, and we have negative work. Negative work is nothing but, let's say some person C is doing some things that hinders the process. Let's say he damages the walls at a rate of, so he takes 6 days to completely demolish. The building. So then it is like negative work. So then work rate will be negative. So it will be minus 1 by 6. So if we take A, B, and C are working together and C is like hindering, how many days it takes to completely finish the construction? Let's say after the construction is done, C is not doing anything. Only until the building is fully complete, he is going to damage. So in that case, the work rate will be 1 by 2 plus 1 by 4 minus 1 by 6. So LCM is 12. So we have 6 plus 3 minus 2 divided by 12, 9, 7 by 12. And so the time taken will be 1 by 7 by 12, which is 12 by 7. So 12 by 7 is close to 1.7. So 1.7. You can see because C is like hindering the process, it is taking more days to complete the work. So this is concept of negative work. And sometimes they may define something called as the efficiency. They will say A is twice as efficient as B. So what it means? So it is similar to saying A has twice the speed of B. So if you give any work to A and give the same work to B, so let's say B takes 8 days to complete, then A will do it in 4 days itself. So he's like twice efficient. So twice efficient means the work rate is twice, or the time taken is half. So this is the concept of efficiency, right? So in the next lecture we'll see some problems, how to solve them, so that you get a better understanding of these concepts. Thank you.